Right, well, it's 8:30 on Tuesday the 6th of November, and we're here at a new site on Southampton Water. That's Forley oil refinery over there. Some blocks of flats here, and here's Dick with our magnificent new stand, which Dick has invented by purchasing. What did you do? You got to...
We've got two ironing boards, took the boards off and just used the legs and a bit of tubing, some bracing with some thin rope and some webbing to rest it on, and it's a nice foldable stand.
Excellent. What we're doing here is, because this is actually in the sea, although it doesn't look much, we have a little bit of waves, don't we? And there's a southerly wind, so it's blowing up that way towards those big ships, blowing onshore, in other words, so we think it'll be safe to let Woodstock loose in this new...
Blowing up from the direction of the chimney.
Okay, from the direction of that chimney there. So if anything goes wrong, he should be blown onshore. The test site is here. This is Southampton Water. You've got the River Itchen flowing in this way and the River Test flowing in from up here. It's a fairly sheltered site because we've got the Isle of Wight here and the New Forest sheltering us from the prevailing wind, but it is connected to the sea. This is looking back at the beach at low tide, with the launch point being to the right. As you can see, the seabed is pretty flat and the water goes out a long way, but there is quite a steep pebble bank at the edge, and we decided that if we launched around high tide it would be fine. And we're just going to radio control him and see how he goes in this new environment, and also whether we can deduce the wind direction from average roll angle as we can on a lake.
Will we have the circle?
Yeah, the circle is in there.
Yeah. Right.
Yes, so he's programmed to sail straight out for about 160 metres in that direction. So we're launching from the beach near the car park, and he's programmed to go out about 160 metres and then go around this circle in a clockwise direction in order to test sailing at all possible points to the wind. And the wind is from the south, so what should happen is something like this, and I'll speed this up. So because the wind's from the south, he's going to have to tack between P1 and P4. Then he should be able to sail smoothly around here. And when he gets to P14, he may have to tack again. So that is the test that we've set him. And because there's no tacking logic in there, we will radio control Woodstock in this area here to get him through the first few points. Sorry, a clockwise circle. Of about 160 metres diameter, and then to come back, hopefully, fingers crossed.
But I'm not
Do you like it? Do you want me to start?
Yeah, that's on, but not recording.
It's okay. Remember, it's steep there.
We got no wind.
Met Office has let us down again.
Yeah.
Promising decent winds and never delivering. This is what they do. But we are in Southampton Water, so you know it's a fairly sheltered place, isn't it? At least the boat is pointing in the right direction.
And reassuringly, the keel isn't on the surface.
No.
Unless it's filled with water already.
What's going on here? Look at this rocking. It's just the way, isn't it?
Yeah.
See that the red line is out of the water at both ends. You think this keel is giving us a little extra buoyancy after you've made it airtight?
Well, that's what I...
Pushing the boat up into the air.
That's what I hoped it might do.
No, did you? Is that what you wanted? It's taking the top of the rudder out of the...
Well, there's less drag that way.
Oh look, the anemometer is showing something. You've actually got a little bit of wind there now.
Oh, here we go.
Well, we can tell that the thing isn't even going round, so
Exactly.
the wind speed is identically zero, which is bloody marvellous. So this was from a boat going past ages ago, is it? These nice little waves?
There we are, we've got 0.2, we've got briefly 0.6 then.
Briefly had 0.6 m. Is that knots or mph?
mph.
Right.
Average.
Well, Woodstock doesn't seem to mind those little waves coming in. Boat speed is 2.1 mph an hour, but and although Woodstock is pointing in the right direction, he's actually going further downstream to the left, and probably there's a current flowing out of Southampton Water at the moment, which would be causing that. And of course, the autopilot doesn't know anything about cross-track error, so it's not making any effort to correct that. So we launched with radio control on, as you can see from the magenta spots, and then we turned it off, and we were hoping that Woodstock would sail towards P1, instead of which he drifted southwards like this. Let me just remind you what this display has on it. This is a plan map, obviously. This compass rose here shows the actual orientation of the boat with respect to the compass, so it's pointing west at this point. The cyan line shows the direction the wind is blowing from, and the pink line shows the movement of the boat as given by GPS speed over ground. Here you can see that the boat is broadside on to any current that's coming down Southampton Water. The wind is blowing it in a northerly or northwesterly direction, but it's actually moving in a southwesterly direction because the current is more powerful than the wind, which is only 2.4 mph. And we were promised 7 or more anyway. So this went on for a considerable time, with Woodstock getting further and further south. Whilst this was going on, I got a bit fed up, so I launched my DJI Phantom 4 drone and flew out to have a look at Woodstock from the air. You can see here that Woodstock is almost broadside on to the oncoming ripples, but he still mainly pitches rather than rolls. This is looking at the same thing head on. And when we got down to here, at this point, what was happening was, although there was some wind on the boat and he was pointing towards P1, he had no movement at all. So we assumed that what was happening was he was sailing very, very slowly towards P1, but at the same time being carried backwards by the current, and so that the net movement was zero. But just as we were about to give up and think we couldn't actually ever run this test, the wind managed to pick up a bit, and then he managed to sail towards P1. And so we started our circle, and because the wind is from the south, Dick took over with radio control to sail it to P2 and then to P3. It's hit P1, and it should therefore, and I can see it turning round, and it's going back, or it should get into irons now, shouldn't it? It can't possibly sail that way because it's directly into the sun, into the wind. So Dick is going to. Are you going to take radio control from P1 to P2?
Yeah, I am doing so now.
You are, okay. And Dick is managing to sail it just by looking at the telemetry and not looking at the boat at all, which is a novelty. Also a tribute to the telemetry.
Yeah.
Here we've got to P3 and Dick is radio controlling the boat towards P4, and when he thinks he's got sufficiently far to the west, he turns off the radio control in the hope that the autopilot can sail to P4, but it cannot. So it applies full starboard rudder, but the boat does not respond, because to turn 90 degrees to starboard in this situation it would have to turn through the wind, and the boat speed is not sufficient to do that. Now, this is a circumstance that's arisen before in our tests on Horseshoe Lake and on Bray Lake, and as a result of it we put into the helmsman loop a piece of tactical logic which said basically, if you've applied full helm in one direction for 20 seconds and the boat has not responded as you intended, then try applying full helm in the opposite direction. And this is a case where this actually happens in real life now. So you see we've got at the moment we've got full starboard helm and the boat continues moving in the wrong direction. And so at this point, shortly, the autopilot immediately applies full port helm, bringing the boat through 360 degrees anti-clockwise. In other words, it engineers a jibe, and then the autopilot is able to navigate to P4 correctly. So here's the same thing from the onboard Dragon video. Here it's under radio control. At this point the autopilot takes over, turns it to port, and now it's trying to turn back to starboard with full starboard rudder, but nothing's happening. So after 20 seconds of that, the tactical algorithm comes into effect. Turns full to port instead. The boat does a 360 degree anti-clockwise turn. And the autopilot eventually gets it onto the desired heading, and away it goes to P4. So here Woodstock is sailing between P8 and P9 at the extreme left-hand limit of the circle. The red funnel ship looks terribly close, but actually it's a considerable way away.
Red funnel should give us a nice wake from that. It's just got into P11 and is turning to P12. Hopefully.
From P4 it proceeded entirely under autopilot control round most of the rest of the circle like this, in quite an impressive fashion really. And at P14 Dick had to take control again to get it eventually through P14 and to P15, and then it sailed under autopilot control back to base. So we were relieved by that and regard that as a success. You may have noticed that the circular track was somewhat scallop shaped. There is a reason for that, but we don't have time to go into it in this video. In part 2 we will present the analysis of the data that we collected for this trip, and there are other interesting things like the fact that on Bray Lake Woodstock mainly rolls and hardly pitches at all, whereas in the sea he mainly pitched and hardly rolled at all, albeit in different wind states. So we'll get onto that and get onto the question as to whether we can deduce the wind angle from average roll angle. But that's in the next video. Anyway, thanks very much for watching. By the way, this week my broadband was upgraded to VDSL. So now instead of having 14 megabits per second down, 1 megabit per second up, I have 74 down, 14 up. So this will make it enormously much easier for me to upload YouTube videos. You have been warned.